Hello, everyone. We're going to go ahead and get started on our first section for Chapter 7, Section 7.1, which is going to be on percents. So as an overview, you hear a lot of things throughout, kind of your daily life, hearing things saying like clearance, 40% off the lowest ticketed price. And if you go to a store and, you're hearing about this clearance and you have to ask somebody what the price of the discounted item would be, you are definitely not alone. I worked in retail for 5 to 6 years, and this is a question I got constantly. And it was things like that where I would basically pull out my phone calculator in front of them and just like, type it out myself. So knowing how to kind of do those percentages in your daily life will be helpful, aside just from shopping. I mean, just if you hear percentages throughout really any time, especially when it comes to things like taxes is usually a specific percent, so you can figure out how much your tax should be and things like that. So it does come up hearing percentages a lot, so it's good to know how to calculate things using them. So percents have a huge number of applications in everyday life, which we know, so we'll learn what they mean, how to use them, and common mistakes when using percents. So converting between percent, decimal, and fractional forms, we say percent really means hundredths or per hundred. Cent, I believe, is 100 in French. So per cent would be per 100. So this means that 1% is the same thing as saying 1 out of 100. So to change a percent to a decimal, we just need to drop the percent sign. So we drop the percent sign off, and then we move the decimal place 2 places to the left to turn it into a decimal. So if we look over here on the side, we say percent to decimal, we have 2.5%. That's what we want to convert into decimal. Now we want to do this because percent is almost like a common way that we word things, but when we actually calculate it, we use decimals. We don't use the value of the percent itself. We want to use that per hundred value instead of the actual percent. Percent is kind of like an applicable everyday way that we talk about it, but when we write it, we calculate things, we do use decimal. So it's important to know how to change a percent into a decimal. So change a percent to a decimal, we drop the percent sign, so the percent sign goes away, and we take the decimal place wherever it is, and we just move it 2 spots to the left. So something like 2.5%, we move that decimal place 2 spots to the left, that's really in decimal 0.025. That would be the value that we're kind of talking about. If there's no decimal place at all, let's say you have something that's like 6%, you can imagine that's really 6.0%. Move the decimal place 2 places to the left, drop the percent sign, and that's how you have your answer in decimal. So that's how you change from percent to decimal. To change a decimal to a percent, you want to move the decimal point 2 places to the right. So you do the opposite. You take the decimal place, move it 2 spots to the right, and then you add on the percent sign. So instead of dropping it, you then add it on. So you're doing the opposite thing in order to change from decimal to percent as opposed to percent to decimal. Then we also have fractional form. Since we do say that percent is per hundred, we're really kind of dividing by 100. So that really means that we can put things in fractions. So to convert a percent to a fraction, you write a fraction with the percent in the numerator. So the same amount that it is in the numerator, drop the percent sign, and you put 100 in the denominator, and then you can simplify that fraction if you need to. So if you have something like, oh, something is 19%, you take the 19 and you divide by 100. In this case, 19 divided by 100 is just that. It doesn't simplify, but you could simplify it further if you needed to. So something like 20 over 100 is really the same thing as saying 2 over 10, also 1 over 5. So we can kind of reduce those fractions a little bit by taking their common factors and dividing them out. To change a fraction to a percent, so if you want to go from fraction to percent, you change the fraction first into a decimal by dividing it. So whatever that value is, you change it into decimal first, and then you go from decimal to percent using this this way that we set up here. So you take your decimal, you move the point 2 places to the right, you add the percent sign to change it from a fraction to a percent. So these are all the different ways that we can convert between percent and decimal and fractional form. And all different forms will be given to you as you work throughout problems. You kind of get used to seeing all the different formats of it. So as our first example, we're going to convert the following quantities into their respective forms. So for part A, we're going to convert 6% into decimal. B will convert 80% into fractional form. C convert 1.03 to a percent, and D convert 7/8 to a percent. So starting with A, we have convert 6% into decimal form. We said for decimal, the first thing we want to do is drop the percent sign. So really we'll work with 6. And then we move the decimal place. Well, 6 specifically doesn't really have a decimal place, but we can imagine that's really 6.0. So if we imagine 6.0, moving that decimal place 2 spots to the left would make that 0.06, just like that. So we drop the decimal place, we move our decimal 2 spots to the left to get our answer in decimal form. So if we wanted to use any sort of conversions, or if we wanted to do a math problem, we want to use the decimal form. All right. Next one is B, convert 80% into fractional form. So what we said with fractional form is that first thing we do, drop the percent sign and divide by 100. So the first step in fractional form would be 80 over 100. Once we have 80 over 100, we can simplify. Divide the numerator and denominator by 10 to get 8 over 10. And then 8 and 10 are both divisible by 2. So that really simplifies to 4 over 5. So 80 over 100 simplifies into 8 over 10, and 8 over 10 simplifies to 4 over 5. So that would be its fractional form in its simplest form. Then we have convert 1.03 to a percent. So we have a decimal changing into percent. We want to do the opposite in this case. Instead of going 2 spots to the left, we want to go 2 spots to the right. So if we have 1.03, we take this decimal place that's here and we move it 2 spots to the right and add a percent sign. So if we move the decimal point 2 spots to the right, that would make it 103%. So 1.03, move it 2 spots. It does kind of become 103.0, but we can drop the 0.0, and then it'd be 103%. Then lastly, convert 7 over 8 to a percent. So now we're changing from a fraction to a percent. So the first thing we want to do is change 7 over 8 to a decimal. So we changed 7 over 8 to a decimal. So that becomes 0.875. And then we take our decimal point and move it 2 spots to the right and add a percent. So 7 over 8 is 0.875. And we take our decimal place and move it 2 spots to the right. So it becomes 87.5 or 87.5. And add the percentage sign. So it would become 87.5%. So those are some examples of how we change from percent to decimal, decimal to percent, fraction to percent, all those kinds of things. So those are a couple of examples on how we do that. Which leads us into solving problems involving percents. So the most common calculations involving percents usually involve finding a percentage of a quantity. So on this example over here, we have something like 9.1% of 347. It is 31.577. So finding a percentage of a quantity, what's 10% of 500? That kind of thing. So since these are usually word problems, it's really important to know the language that we use to indicate operations as well. So we see here on the sidelines, we have 9.1% of 375 is 31.577. So the word of indicates multiplication. So whenever you see of, you'll multiply those numbers. When you see the word is, this really means equals or the equal sign. So we can kind of translate our statement, 9.1% of 347 is 31.577. When we change that into a math equation, we change from percent to decimal because we always want to do that when we actually calculate things. So this becomes 0.091 times, instead of 347 equals, instead of is, 31.577. So we see how we kind of translated the wording and the phrase that we had into a math equation. So in calculations with percents, it's very common for a result to have multiple digits after the decimal point. So really a lot of times you need to decide if it's appropriate to round to a specific digit or not, or if you're just told to round. A lot of the times we're not really told to round when it comes to concepts with money, and that's because the smallest thing you can have in money is a penny. And a penny would correspond to 1/100th, which would be 1 cent, which is also a 2 decimal spot. So 2 decimal places for money. Other than that, you'll probably be indicated on how many decimal places to round to if you are told, or otherwise. So, all right. Another example, we're going to solve the following problems involving these percents. So we have the question, a real estate agent receives a 7% commission of a house that costs $82,500, probably in the middle of nowhere, because that's how much a house costs in the middle of nowhere. What is her commission amount? So we're going to find the commission amount on selling a house for $82,500 at 7%. Then for B, we have a sales clerk receives a 9% commission on all sales. Find the total sales the clerk made if their commission was 486. So starting with part A, we want to know, what is the commission? It's 7% of 82,500. We heard the word of in there. That should be multiplication. And we have a percent. We want to change that into decimal. So we say 7% decimal is really 0.07. We took the decimal place and moved it 2 spots to the left, drop the percent sign. And we said 7% of 82,500. So we can multiply the 7%, which is now decimal, to the value of the house. 82,500 times 0.07 to get our answer, which was $5,775 in commission. So that's how much you made in commission based on this question. All right, so then part B. Part B is a little different because now we have that the sales clerk receives 9% commission on all sales, but now you want to find the total sales that the clerk actually made in order to get the commission of $486. So now we're saying 9% of sales, which we don't really know, is $486. So we don't know how much the sales is, but we know how much the commission was. So 9%, of course, we changed to decimal. 9% is 0.09. And T we can say is the total sales. So we know that T, our total sales, times 0.09, the percentage of the commission, will equal the actual commission amount, $486. But we don't know what T is, and we do have it being multiplied by a number, so we can instead set this up so that we're solving for T instead of solving for the commission. We do that by dividing each side by the 0.09. If T is being multiplied, we can get rid of that by dividing by the same value. So dividing each side by 0.09 gives us the total sales is 486 divided by 0.09, which gives us our answer of 5,400. So total sales must have been 5,400 in order for the sales clerk to receive a commission of $486 at 9% commission. So, all right, there's an example on following along a problem that just involves percentages. So now we can do things like find percent increase or decrease. So steps for finding percent increase or decrease, our first step is to find the amount of increase or decrease. So find out how much did it increase or how much did it decrease by. Then 2, make a fraction that is shown below. You want your amount of increase or decrease divided by the original amount. So whatever the original amount of whatever the item, whatever it is, you take that value, and it is going to be then the denominator of the fraction where you have your amount of increase or decrease divided by the original amount. Then you take your final answer, you change it to a fraction or a percent. Most often percent, but potentially could be a fraction, but most often percent. So we can find that percent increase or decrease using this fraction that we have here. You take the actual amount of increase or decrease and divide by the original. When finding percent increases or decreases, you want to make sure you divide by the original amount, not an ending amount. So it's always good to identify what is the original amount before you start dividing anything. So that's how we'll calculate percent increase and decrease, which we can use for our example. So we say the city government spent 72,500,000 last year, and is projected to spend 64,300,000 this year. How much was the budget cut since last year? So we're saying that last year we spent 72,500,000, and this year we're projected to spend 64,300,000. So that was obviously a decrease. We went from about 72 million to about 64 million. So we definitely decreased, but we want to know how much was the budget cut. And in this case, we are going to answer with a percentage like number, not the value number, because we just learned about how to find percent increase and decrease. So we want to find out how much was actually cut. What was the amount of decrease? So we take our original amount and we subtract the new amount. So 72,500,000 minus 64,300,000 tells us the amount of decrease was 8,200,000. So that's how much our budget decreased. But now we want to find the percentage. How much percentage-wise was the budget cut last year? We'll round our answer to 1 decimal place. So we take our amount decrease, which was 8,200,000, and we divide by the original. The original is what we're saying was last year's. So the original was 72,500,000. So we divide our amount of decrease by the original to get 11.3%. That's how much we should have gotten. The value that should have come out was a decimal, and then we want to move that decimal point 2 spots to the left to give it our answer in percentage, 2 spots to the right to give it in our percentage. So really, this should have ended up being probably 0.113, which then we change into 11.3%. So that's how much the budget cut was since the previous year. It was cut by 11.3%. So now we can evaluate the validity of claims based on percents. So we've seen a lot on like how to calculate percentages. Now we can kind of look at like how they're very commonly misused. So percent increases and decreases are very often misused, sometimes intentionally and sometimes not. So they're often overestimated or underestimated. So by making a blanket statement, if somebody doesn't truly understand kind of how percents work, you know, maybe they say it on purpose because they know that they'll get your attention better, but there's like a catch. Or maybe they really just don't know. So if you ever encounter a problem that's a bit more abstract, for example, you can always turn it into a concrete problem by choosing specific numbers to test out the question. So if you're being told some statement, you know, come on in, it's 10% off, and then an additional 5% off, that's 15% off. It's probably not for 15% off. That's not exactly how percentages work. But if you wanted to test it out, you could pick a random object that costs a random amount of money, whatever you like, and then try to work it out yourself. And you can see if it's actually true or not. Which is what we're going to do for our example. So we say a department store is advertising that some merchandise is 25% off. An additional 10% off discount will be given to the first 100 customers as well on a specific day. The advertisement then states, this is a 35% markdown. 25% plus 10% off, that's 35%, right? Not quite. So we're going to figure out, is this true? The hint, probably not, but we're going to go ahead and we're going to check that out. All right, so here's our question one more time. We have a discount store is advertising some merchandise, it's 25% off. An additional 10% discount is given for the first 100 customers on a specific day. The advertisement states this is a 35% markdown. Then we want to check, is it true or not? So when we check if it's true, we want to use an actual item. We want to use like a tangible item, something that has price. So let's go ahead and just pick like an easy price. Let's say I'm looking at one item and it's $100. So we'll have a value. $100 for the price of a random item. It could even be multiple items. It really doesn't necessarily matter. You're just picking a value. You want to make it easy because nobody wants to calculate like $57.36 of something. So we'll pick an easier value. We'll start with 100, kind of see how it works. So if we pick $100 and we want to think about like the markdowns, first we can start with what is 35% off of $100? We would say 35% of $100. Well, we see the word of. That's really going to be percent, which is really turned into decimal, times 100. So 35% in decimal is 0.35. We take an imaginal decimal point here and we move it 2 spots to the left, add a 0 in the front. So this becomes 0.35 times 100. So we multiply those values together, we end up getting 35. 0.35 times 100 is 35. And this amount that we're talking about here, this is dollars. So we're saying 35% of $100 is $35. That's the markdown of 35%. So this means a 35% markdown of $100 would be $100 minus $35. That's how much the markdown was. It was $35 off, making your item now $65. So $65 is kind of like the value that we're kind of aiming for here. We're saying $65 is 35% off. So when we do the rest of our calculations, we're really checking if the value that we get is $65, because that's what they're promising. They're saying, hey, it's 25% off. You're getting an additional 10% off. That's 35%. So when you go in, you're expecting to get $35 off of 100. But let's see how much you really get. So we're taking that same value still, but now we're having start with 25% off. What is 25% off of 100? Ooh. So it's kind of like one. This is the second one. So 25% off of $100. We use the same calculations as before. That's going to be 0.25 times 100. 25% in decimal times 100. It's coming out to $25. So we have $25 off. So we can state that a 25% markdown of $100 would be 100 minus $25, which makes it $75. So an item that's 100, it's discounted 25%, makes it 75. And then we're getting an additional 10. But what we do now is that it's already been marked down. When we get an additional 10% off, we're getting 10% off $75, not the original 100. So when we do our next step, this is 10% off 75, not 100. But we'll see how much that is. So 10% in decimal would be 0.1. Move our decimal place 2 spots to the left, times 75. Because we're talking $75. So 0.1 times 75 actually comes out to $7.50. Not $10 if you took it off of 100. So you have now a markdown of $7.50 off of the 75. So a 10% markdown of $75 would be $75 minus $7.50. So we subtract that from $75 and $75 minus $7.50. This ends up giving us $67.50. So the promise was 35% off. So if you had $100, 35% off of $100 is $65. But if they say, hey, it's 25% off with an additional 10%, that was $67.50. Sure, $2.50 is really not that big of a difference. But they were not using percentages correctly. It's still different than you thought. Maybe you had $65 exactly and you wanted to spend $65 exactly. You walk in there, it turns out you can't buy that item at all if it's $67.50. So having percentages and using them normally is going to be a lot better. So let's just say, well, really, what is $67.50? Like, how much of a percent off is that really? So we would say we definitely 67.50 or $67.50, definitely more than 65. So 25%, 10% off, definitely not the same as 35%. But we can find the percent increase or decrease. So we can find the percent, the amount decrease from the original amount, which was $100. And we subtract 67.50. This gives us $32.50. So the amount or the percent decrease would be $32.50 divided by 100, the original amount. And this gives us the value of 32.5%. So having 25% off and then an additional 10% off was really 32.5% off, not 35% off. So we can do calculations like these, kind of prove company's wrong, maybe they're doing it on purpose. They're like, hey, it's 35% off. So you think it's 35% off, but it's really not. And for purchases like $100, it's probably not going to be that big of a deal. It's not going to be that much of a difference. But if you're making much larger purchases, that can definitely be a difference. So it's always good to kind of look into those things, kind of analyze what companies are saying. So, all right, let's go on back over to our lecture. All right, so we finished our example. We said it was not true there. And that wraps up section 7.1. So in 7.1, we learned converting between percent, decimal, and fractional form, solving problems involving percents, finding percent increase and decrease, and evaluating the validity of claims based on percents. So, all right, that wraps up section 7.1, and I'll see you in the next one.